In preparation for next class period, you're going to take your notes about matrices and some basic operations, and then next time we'll get the practice in class. So a matrix is this thing that you see down here, and it is a rectangular ordered arrangement of numbers in rows, and then I'm use a different color, and columns. So let's make sure we know. A row is anything going horizontal, so this would be a row. 5, 7, 1 is also a row. So our rows are the horizontal things. And then our columns are the vertical. So like 3, 1, 9, 7, 11, 5, those are all columns. Those are going to be important because we're going to need to know the sizes of these matrices, and so make sure you know the difference between a row and a column. The last thing there is going to be there's elements. So each of these numbers, 11, 9, -3, 5, 7, and 1, is called an element in our matrix. So that's some of the basic vocabulary for you. So now let's go through. A dimension of the matrix is simply the size, right? And we label the size of that matrix by the number of rows and columns, or by columns, you could say. For example, this would have 2 rows and 3 columns, so it is called a 2 by 3, or you could call it a 2 by 3, kind of like a piece of plywood, meaning it has 2 rows and it has 3 columns. We are going to learn how to do some basic operations with these matrices, and so something that you need to be aware is as you're adding or subtracting the matrices, the dimensions, meaning our rows and columns must be the same. So we have, before we go through our adding or subtracting or doing some operations in matrices, let's go ahead and identify the dimensions of each matrix. So this one has 1, 2 rows, so it's a 2. Has 1, 2, 3 columns, so it's a 2 by 3. What about this one? 2 rows, 2 columns, so we call it a 2 by 2. Finally, this last one looks kind of similar. It's a 2 rows, 2 columns, once again, a 2 by 2. So, as we're performing the operations, we are going to use these 3 matrices above. And the first thing we're going to try is adding matrix B to matrix C. So all that is saying, if we rewrite our matrix B and C, matrix B has a 9, a -8, 3, and a 2. Be sure to keep the same order as above. Then it has a -10, a 0, a 5, and a -6. As we add the 2 matrices, first you have to say, okay, are the dimensions the same? We've got a 2 by 2 and a 2 by 2. They are, so we can add this. Next, all you do, so I guess that should lead you to, we're going to have a 2 by 2 in the end. So if you want to kind of think about that before we get started, go for it. So now, all you're going to do is notice like this first row, first column, we have a 9, and then we also have a -10. So all we're doing is we're adding those 2 numbers. 9 plus -10 is a -1. If we keep in that same first row, but we go to the second column, first column, but the second row. So we've got 3, and then we've got a 5. All we're doing is adding 3 plus 5, which is 8. And then you just do the same for the other 2 numbers. So -8 and 0 are in the same position, so that is -8. 2 and -6 are in the same position, that gives you a -4. So as we look at the next one, A minus C, we're looking at a 2 by 3 minus a 2 by 2. So remember, our one key thing up here, to add or subtract matrices, the dimensions must be the same. A 2 by 3 and a 2 by 2 are not the same, so this one is actually impossible. We cannot add these things or subtract these things together because the dimensions are not the same. I can't spell. Dimensions are not the same. Okay, this next one is called -4 times A, and we call that scalar multiplication. So it's actually not addition or subtraction. We're trying to multiply. But all it means here is that all elements are multiplied by that number. So -4 times the matrix A. And this you can do with any size matrix. So we did -4, and then we're multiplying that times. Matrix A is 3, -4 is 7, -1 6 0. As we multiply that, -4 times 3 is a -12. -4 times -4 is 16. -4 times 7 is -28. -4 times -1 is +4. -4 times 6 is -24. And -4 times 0 is 0. So we end up with the same size matrix of 2 by 3, but it is -4 times bigger. Or smaller, sorry. Okay, the last one, we're just doing two things. We are going to do our scalar multiplication and then subtraction. Think about your order of operations. We do need to multiply before we subtract. So, let's first find 2c. So 2c is 2 times matrix C, which is -10, 0, 5, -6. So you're doubling everything in matrix C. 2 times -10 is -20. 2 times 0 is 0. 2 times 5 is 10. 2 times -6 is -12. Or sorry, yep, -12. So now what we're going to do is we're going to take 2c minus b. So matrix 2c, -20, 0, 10, -12 is a 2 by 2. Minus matrix b is also a 2 by 2. 9, -8, 3, 2. So since they are the same size, we can perform this operation. You can do this two ways. You can either do -20 minus 9 and tell me the answer, or I would actually suggest, so since we're doing a minus this, doing minus this matrix is really the same thing as distributing a -1 to this entire matrix. So I would recommend distributing the -1 to begin with. So it's -9, a +8, -3, -2. And now we're just adding the matrices together, and you'll probably be less likely to forget about that subtraction sign. So -20 plus a -9 is -29. 0 plus 8 is 8. 10 plus a -3 is 7. -12 plus a -2 is -14. Great. You now understand the basic operations of matrices. So let's look at some applications here. As you turn to the back side of your notes, the first application here is we have the information below shows how many books you have read, books and magazines, and their type that you have read over the months of June, July, and August. And so a matrix, as we know, is that ordered arrangement of numbers. We can simply take something like this table, and we can form it into a matrix. So it would just be the matrix 2, 4, 3, 1, 4, 5. All it means is this first column means it's paper, second column means it's online, fiction, nonfiction, magazines. And then our second matrix of July, same idea, just take the numbers and put it in matrix form. We got 3, 2, 1, 1, 5, 3. And then our last one would be 1, 3, 2, 3, 4, 6. So just a little different format, same idea of what you see in the table. So if I wanted to find the total of each of these types of books and magazines we've read over the months, that's another way to say let's just add our matrices. So if I add these three matrices together, we're doing 2, 4, 3, 1, 4, 5, plus 3, 2, 1, 1, 5, 3, plus 1, 3, 2, 3, 4, 6. Since they are all a 3 by 2s, we can all add them together. And when we do that, we just have 2 plus 3 plus 1, which is 6. 4 plus 2 plus 3, which is 9. Why don't you finish off the rest of the matrix, and so pause the video for a second, and I'll fill it in. So once you finish up, you should have the matrix 6, 9, 6, 5, 13, 14. And as you look at this first row represents your paper, right? Sorry, first column. The second column represents your online. Your first row, this would just be how many total fiction, nonfiction, and magazines. Okay, one last one. Let's look at some pet nutrition. So it says, use the table that gives nutritional information for 2 types of dog food. Write the 2 matrices that represent the percent of protein, fat, and fiber, so we just want the percents, one for mix A and one for mix B. So if we wanted our matrix for mix A, since we want the percent of protein, fat, and fiber, it would make sense to just have 1 row and 3 columns, 1 for each of those. So like 22, 12, and 5. And B, we have to keep things in the same order. So since we started with protein here, I got to do protein just below it. 14, 8, and 8. And now we have 1 by 3 matrices. The first one represents mix A, second one represents mix B, but all of our columns mean the same thing. So if you wanted to find the difference in the percent of protein, fat, and fiber between mix B and mix A, we are talking about the operation of subtraction, right? And since we want mix B and mix A, I would interpret that as we want to do matrix B minus matrix A. So if I write that out, I've got 24, 8, 8, minus 22, 12, 5. Remember our trick with subtraction? Rather than just doing minus, we could change that to a plus, change these to the opposite sign, so minus, distributing that negative. So we get 24 plus a negative 22 is 2. 8 plus a negative 12 is negative 4. 8 plus a negative 5 is 3. Which means the difference between them and the percent protein is 2%. The percent fat is a negative 4, which means that mix A has more percent fat than mix B. And then on number 3 would be the percent of fiber. And since we kept our columns all the same, we know that's exactly the difference in those percents. Okay, that's all for now. Don't forget to take your 5-question Canvas quiz.